Hello, my name is Riley Burne. I'm a student at ACU enrolled in the unit Mechanical Basis of Exercise, and this is my assignment 2, or Mechanical Changes presentation. I've chosen the counter movement jump as my mechanical changes task. My mechanical outcome of interest is the vertical velocity of the hip at takeoff. My implemented change to my movement is the exaggerated arm swing. I'll be using cameras, calibration videos, tracking software, and Excel to compare the difference in vertical velocities between these two movements. The results will help support the reasoning behind the biomechanical concepts relating to these movements. Video capture. The video was captured using a digital camera with a frame rate of 240 Hz, or 240 frames per second, a shutter speed of 1/800 in manual focus. The camera was set up on a tripod. 3 videos were captured. An initial video was recorded, which was required for calibration. In the calibration video, the subject stood in front of the camera holding a calibration stick. The calibration stick had a length of 0.52 meters, and it was held for the entire video. The second and third videos contained 2 different counter movement jumps. The first video involved the subject performing a regular counter movement jump with their arms on their hips. Within the second video, the subject performed a counter movement jump with the addition of an arm swing. There was time before the jump occurred and after the jump concluded within both videos. Calculations. The difference in vertical velocities between the counter movement jump and the exaggerated arm swing counter movement jump was calculated using the tracker software, Excel spreadsheets, and relevant formulas. Before filming, a marker made of sticky tape was placed on the subject's hip. This was necessary for the tracking process, and vital when determining the results. The calibration video was used in the tracker software to insert a calibration stick. The stick was used for both videos for reference to the meters travelled. The subject's hip was tracked within both videos, ensuring that a marker was precisely placed on the hip marker within each frame. After the tracking process was concluded, time, horizontal, and vertical data was provided from each marker within each frame between both videos. The vertical velocity is the measurement we want, so we can ignore the horizontal data or the x-coordinate. Both sets of data from the 2 videos were copied and pasted into an Excel spreadsheet with appropriate titles. The frame where the foot leaves the floor during takeoff was noted between each video. This is the frame that will provide the greatest vertical velocity at the hip, so it's necessary that we calculate the vertical velocity at this frame, or frames around that point. The central difference method was used to calculate the vertical velocity at the point of takeoff. The vertical velocity at the point of takeoff was calculated by dividing the displacement of the frame ahead by the frame behind, and dividing the change in displacement by the change in time before and after the frame. This calculation can be seen to the right of the presentation. It's in the Excel format. Below vertical velocity, you can see the Excel formula or central difference method for vertical velocity. This method was used for both jumps at the frame of takeoff. The calculation provided the results, and the results were used and compared and placed into graphs. Results. The results reflected the difference between hip vertical velocities between the normal counter movement jump and the counter movement jump with the exaggerated arm swing. Results reflected that the vertical velocity was much greater in the exaggerated arm swing. The vertical velocity of the hip in the normal counter movement jump was 1.98 meters per second. The vertical velocity of the hip in the counter movement jump with the exaggerated arm swing was 3.56 meters per second. Biomechanical concepts. The results reflected that the vertical velocity of the counter movement jump is greatly influenced by the exaggerated arm swing within the movement. The counter movement jump is influenced by certain biomechanical concepts, such as the impulse and momentum relationship, angular velocity, and ground reaction force. The exaggerated arm swing enhances these biomechanical concepts to produce a greater vertical velocity. Concept 1. Impulse is the change of momentum of an object when force is applied over time. During a counter-movement jump, there is a relationship between impulse and momentum. An increase in force or an increase in force applied over time correlates to a greater impulse. A greater impulse results in an increase in momentum. This results in a greater vertical velocity. The addition of the exaggerated arm swing during the movement causes an increase in momentum, impulse, and therefore vertical velocity at the hip. Concept 2. Angular momentum and body segmentation. During the counter movement jump, different areas of the body, for example the hip, thigh, torso, and ankle, coordinate together to effectively generate force during the jump. The transfer of force between different areas results in an increase in vertical velocity at takeoff. The additional arm swing produces an increase in angular momentum from the upper body. This translates to an increase in vertical velocity at the hip during takeoff. Concept 3. Ground reaction forces. Ground reaction force is the force exerted by the ground on the body in response to the force the body applies to the ground. With reference to the counter movement jump, an increase in ground reaction force will result in a greater vertical velocity. This is due to the increase in force production by the body. The additional exaggerated arm swing enhances the ground reaction force. This is due to the increase in downward momentum produced by the upper body. The increase in downward momentum causes the ground to exert a greater amount of force onto the body. The body compensates by producing more force. The increase in force results in greater vertical velocity at the hip.